Hello everyone. Today we're going to continue our stoichiometry series by calculating empirical and molecular formula, a very common question iGCSE and IB examinations. Now in these questions you get data of the mass of the different elements in a compound. This is found by a process called elemental analysis. Usually using combustion you find out how much of each element there is in your compound. So once you have the mass in grams, as we can see on the top here, the first step is to divide by each element's atomic mass, which we find in the periodic table. So for carbon, if we just round up, it's 12 grams per mole. For hydrogen, 1 gram per mole. And for oxygen, 16 grams per mole. Now, dividing mass by AR, atomic mass, we find the moles of each element. And we get the following. And this row is all in mole. One 724. And we get 0.5825 mole. The next step is to see all these numbers and find the smallest of them and divide all of them by that number. So in this case, it's quite simple. We divide all the numbers by the smallest number. This is just to find a ratio between them in whole numbers. So divide all by the same number. And in this case, it's quite easy. We see that we have, for every 1 mole of carbon, we have 2 moles of hydrogen and 1 mole of oxygen. And that gives us the information that our formula, our empirical formula, is CH2O. Now, the empirical formula is the simplest whole number ratio of atoms of each element. So it's not necessarily the actual formula, which we call the molecular formula. So this is the empirical formula. Now, in the question, often they're going to say, give you some extra information. What is the molecular mass of the actual formula? Now, to begin with, so they're going to give you a value for that. So usually they say MR is equal to 90 grams per mole. That will be given in the question. What you need to do is find the MR of your formula you calculated, the empirical one, which in this case, again, we take values from the periodic table, 12 for carbon, 2 hydrogens each one, so 2, and 16 for oxygen. This is in grams per mole, so we get 30 grams per mole. This is the MR of our empirical formula. So all you have to do in these questions is compare these two numbers, 90 grams per mole and 30 grams per mole. We see quite clearly that there is a ratio of 1 to 3. So you can divide the big number by the small number, we see a ratio of 3. So in fact, our molecular formula is 3 times our empirical formula. And this gives us our final answer, molecular formula. Actual number of atoms of an element in a compound. And in this case, we have not 1, but 3 carbons, 6 hydrogens, and 3 oxygens. And that is our final answer. So in exams, you see this as a 2-part question. 1 to find the empirical formula and 1 to find the molecular formula. They must give you this extra piece of information here to do this. Another small remark is that often they will not give it in grams, but in percentage. But that is okay, because if you assume that you have 100 grams of the sample, then you can convert that immediately to grams. So 80%, 80 grams. Thank you for listening, and join us next time for more stoichiometry.